My structural engineer saved me $19,000 with one sentence. Skip the framed gable roof sitting on top of your containers, go single slope instead. I thought he was overcomplicating a simple decision. Single slope roofs look modern, industrial modern, not like a traditional home. Why would an engineer push that hard for a container build specifically? Turns out, structural engineers know something most container builders never get told up front. Single slope isn't just cheaper on a container home. It's structurally smarter, faster to build, easier to engineer against the container's existing steel frame, and it solves problems that a conventional framed roof creates the moment you set it on top of a shipping container. Today, I'm showing you exactly why engineers prefer single slope for container construction specifically, the real numbers behind it, and something most container videos never explain: how a single slope roof actually solves the corrugated steel heat and condensation problem that every container owner eventually runs into. If you're new here, we cover container homes with real engineering data and honest numbers every single week. Hit subscribe before we get into this, because the cost breakdown later in this video is going to change how you think about your roof budget entirely. Let's start with the problem, because you need to understand what most container builders are actually doing before you understand why engineers steer people away from it. A container's native roof, the corrugated steel panel welded across the top when it was built as cargo equipment, was engineered to survive being stacked 9 containers high on an ocean freighter, not to shed water and manage thermal load as a residential roof for the next 30 years. So when builders want a real house roof, instead of a flat industrial top, they frame a conventional gable or hip structure on top of the container, essentially building an entirely separate roof system that sits above the existing steel shell. And that's where 3 expensive problems show up, every single time. Problem number 1. Complex truss engineering built on top of a structure that was never designed to carry it. A gable roof spanning a typical 2 or 3 container footprint needs engineered trusses set every 24 inches, custom fabricated, load calculated, and in most cases requiring an added bearing wall system framed on top of the container's top rail, since the corner castings were engineered for stacking loads, not for a new roof structure bearing unevenly across the panel. Cost for that truss system on a typical 3-container build, including the bearing wall framing needed to distribute the load correctly, runs $16,000 to $24,000. Problem number 2. Multiple load paths your engineer has to calculate from scratch because they're not native to the container's design. A gable roof distributes weight in several directions at once, down through the trusses to the bearing walls, out to the ridge beam, laterally to resist racking. And every one of those load paths has to be reconciled against a structure whose real engineering was done for shipping, not home building. Your engineer ends up treating the roof as an entirely separate structure sitting on top of the container rather than integrating with it, which defeats a big part of the reason people choose container construction in the first place. Problem number 3. Complicated connections at exactly the point where 2 completely different materials meet. Where a framed gable roof lands on a steel top rail, you need transition flashing, structural connectors rated for both wood to steel and steel to steel loading, and a weatherproofing detail that has to perform across 2 materials with different expansion rates. That transition line is also where condensation risk concentrates, because warm framed roof cavity air meets cold container steel directly below it. Single slope eliminates all 3 of these problems by working with the container's existing structure instead of building an unrelated roof system on top of it. Let me show you exactly how. Reason number 1, no trusses required. A single slope roof spans in one direction only, from the tall wall to the short wall, and that load travels through purlins, simple horizontal members set every 4 to 5 feet, running directly across the container's existing top rail and corner castings, the same structural points the container was originally engineered to carry load through. Cost comparison for a typical 3-container, roughly 960 square foot footprint. Gable truss system with bearing wall framing, $16,000 to $24,000. Single slope purlin system, $5,500 to $8,500. Savings, $10,500 to $15,500. Reason number 2, a single load path your engineer can calculate in a fraction of the time. The entire roof load travels one direction, straight down the slope to the tall wall, then directly into the container's corner castings and the foundation below. Engineering time for a typical 3-container home. Gable, including bearing wall and truss to container connection analysis, 14 to 20 hours at $150 an hour, $2,100 to $3,000. Single slope, 6 to 9 hours, $900 to $1,350. Savings, $1,200 to $1,650. Reason number 3, dramatically simpler connections. A single slope roof has exactly 2 primary bearing points, the tall wall top rail and the short wall top rail. No ridge beam, no hip or valley rafters, no complex flashing transitions across multiple material systems. Labor for roof framing alone on a 3-container footprint. Gable, 9 to 13 days with a 4-person crew. Single slope, 4 to 6 days. Savings, $5,200 to $7,800. Those are the structural reasons. But here's where it gets specific to container construction. And this is the part most single-slope roofing content never touches, because it's not a barn-dominium problem. It's a corrugated steel problem. We've talked before on this channel about how brutally hot a bare corrugated steel roof gets under direct sun. Surface temperatures climbing past 150 degrees Fahrenheit, even when the air outside sits comfortably in the 90s. And how that heat marches straight through the steel into your living space if you don't manage it correctly. A single-slope roof solves a piece of this that a lot of container builders don't realize they're solving until they've already built it, because a properly designed system doesn't sit flush against the container's original roof. It's elevated on the Purlin system, typically 4 to 8 inches above the native panel, creating a continuous ventilated air gap running the full length and width of the structure. Hot air trapped in that gap, heated by direct sun hitting the new upper roof surface, rises and exhausts through a ridge vent at the tall wall end, pulling cooler outside air in at the low wall end continuously. This is a passive convective cooling channel, and it means the container's original roof steel, the surface actually forming your ceiling below, is shaded from direct sun entirely and separated from the hottest air by that ventilated gap. Builders who've measured this report interior ceiling surface temperatures 15 to 25 degrees cooler on a vented single slope system compared to a container with roofing applied directly against the original steel with no air gap at all. That's a meaningful reduction in cooling load before your mini split or your earth tube system ever has to do anything. The second container-specific benefit is condensation management, and this is a genuine engineering concern on steel structures, not a marketing point. When warm, humid interior air meets cold steel, moisture condenses on the underside, which over time leads to rust on the original roof panel, and, if organic materials are touching that steel, mold risk inside the wall or ceiling cavity. A vented single-slope air gap keeps convective airflow moving continuously across the top of the container's original roof surface, which meaningfully reduces the humidity differential that drives condensation formation in the first place. This doesn't replace proper closed-cell spray foam insulation on the interior, which remains your primary defense, but it's a second layer of protection a sealed, unvented gable roof sitting directly on the container typically doesn't provide, because a sealed cavity traps whatever moisture gets into it instead of continuously flushing it out. The Purlin system itself can be welded directly to the top rail and corner castings, or bolted using structural fasteners rated for your wind and snow zone. Welding produces the strongest possible connection, and is what most engineers prefer for high wind or heavy snow regions, since there's no mechanical fastener to work loose over decades of thermal cycling. But it requires a certified welder and typically runs $6,800 to $9,500 for a 3-container build. Bolted connections are faster, usually done in a single day by a standard framing crew, and cheaper at $4,800 to $7,200. Though they need periodic inspection, since mechanical fasteners on steel are subject to loosening from thermal expansion over time. Most engineers consider bolted adequate for moderate wind and snow zones, and recommend welding once you're past 130 miles per hour wind or facing sustained heavy snow. Either method still outperforms an equivalent wood frame Purlin connection in wind resistance, because you're tying directly into a steel structure already rated for far greater loads than typical residential framing. Now let's talk about performance, because engineers don't just care about cost, they care about how the roof actually holds up. Performance advantage number 1, wind resistance. A single slope roof presents a clean aerodynamic profile, No hips, no valleys, no complex intersecting geometries creating turbulence and uplift pressure at multiple points. On a container home specifically, that simpler wind profile pairs with the container's already high structural rigidity. A framed gable roof in a 130 imp zone requires hurricane straps at every truss-to-bearing wall connection, a reinforced ridge connection, and braced gable end walls. A single slope roof in the same zone requires standard connections along one continuous load path, with simpler bracing throughout. Engineering verdict: single slope is structurally simpler and more conservative in high wind zones because it has fewer connection points where failure can initiate. Performance advantage number 2, snow load management. A single slope roof sheds snow continuously in one direction, straightforward and predictable to calculate. A gable roof accumulates snow unevenly, and where two roof planes meet, drifting can concentrate load significantly above the uniform ground snow load your engineer started with. 5 to 2 times ground load locally, sometimes exceeding 90 to 100 pounds per square foot at concentration points. A single slope roof sheds snow uniformly, with proper pitch, typically a minimum of 3 and 12 for heavy snow regions. Engineering verdict: single slope is significantly simpler and more predictable to engineer for snow country. Performance advantage number 3, water drainage. Single slope roofs have exactly one drainage direction. Water flows down the slope and off the low edge into gutters. Gable and hip configurations create valleys wherever two roof planes intersect, and valleys concentrate water flow while being the most common leak point on any roof. On a container specifically, adding valleys on top of the existing steel-to-frame transition multiplies the number of points where water infiltration can find its way into the structure. Single slope eliminates valleys entirely. Single slope performance depends heavily on adequate pitch. Engineers typically recommend a minimum of 1 in 12 for standing seam metal generally, 2 in 12 or greater for genuinely reliable snow and water shedding, and 3 in 12 or steeper in heavy snow regions. On a container home, that pitch also determines the height of your ventilated air gap at the tall wall end, tying directly back into the passive cooling benefit we just covered. So if single slope is cheaper, structurally simpler, integrates better with the container's existing steel, and performs better in wind, snow, and heat management, why doesn't every container builder choose it? Here's what you actually give up. Trade-off number 1, the traditional home aesthetic. A single slope roof on a container reads as modern, industrial modern, intentional. If you're trying to soften the container's industrial identity toward a traditional farmhouse or cabin look, a gable roof does that more convincingly. No way around it. Cost of that aesthetic: $16,000 to $22,000 extra over an equivalent single slope build. Trade-off number 2, interior ceiling variation. Because the container's interior height is fixed at 8.6 inches on a standard high cube, the single slope structure sits above that fixed ceiling rather than replacing it, so the dramatic vaulted effect isn't automatic on a container unless you design for it. Getting a real 12 to 14 foot interior peak means opening the container's original roof panel into the new Purlin structure, adding $8,000 to $14,000. Trade-off 3 and 4, briefly. Achieving proper pitch creates a real height difference between your tall and short walls, roughly 5 feet on a 20-foot wide double container build at 3 and 12, which means more framing and higher wind-rated connections on the tall side. And orientation matters, since the tall wall carries the big windows and the view while the short wall doesn't, so site planning before you set the container is essential. Let me show you the complete cost difference for a typical 3-container, 960 square foot build. Gable roof system on containers. Engineered trusses plus bearing wall framing, $19,500. Structural engineering, $2,500. Roof framing labor, 11 days, $8,800. Ridge beam and connections, $3,600. Complex flashing at valleys, $3,200. Total roof structure cost, $37,600. Single slope system on the same build. Purlin system, welded, $7,200. Structural engineering, $1,100. Roof framing labor, 5 days, $4,000. Top rail connections, $900. Straightforward single direction flashing, $1,000. Total roof structure cost, $14,200. Total savings, $23,400. Important note, both roof systems in that comparison use the same standing seam metal roofing panel, the same insulation package above the container's original steel, and the same underlayment. The $23,400 difference is purely structural complexity. Trusses and bearing walls versus purlins, engineering time and labor. Exactly the same category of savings the barn-dominium world discovered years before container builders caught on to it. Choose single slope if you want to save $20,000 to $25,000 on your roof structure. You prefer the modern, industrial, contemporary aesthetic. You're in a high wind or heavy snow zone. You want faster construction. You want the passive ventilation benefit for the corrugated steel heat problem. And your lot allows tall wall orientation toward your best view. Choose gable if a traditional silhouette is worth $16,000 to $22,000 to you. Your hoe requires it. Check that in writing, or you're building for resale in a conservative local market. Important, check your local building codes before you finalize anything. Some jurisdictions restrict single slope pitches, and a growing number of counties still don't have a clear code category for container residential construction at all. Get any interpretation from your local building department in writing. My structural engineer's advice, unchanged from the day he said it to me. Single slope is the smartest roof system for container homes specifically, not just barn-dominiums. Simpler engineering that works with the steel instead of fighting it, better performance in wind, snow, and heat management, and a real solution to the ventilation problem most container builders don't know they need to solve until they've already moved in. He was right. I saved $23,400 on the roof structure alone, and my build timeline finished nearly a week faster than the gable alternative I almost chose instead. What's your situation? Are you building in a high wind zone, heavy snow country, or do you value that traditional home silhouette enough to pay extra for it? Drop your state, your container configuration, and your biggest roofing concern in the comments, and I'll tell you what engineers working with container construction in your region typically recommend. Subscribe for real container home breakdowns with actual engineering data and honest trade-offs. No fantasy numbers, no sponsored fluff. See you in the next one.